Welcome to Engineering Shiksha. The reason behind starting this channel is due to the ongoing pandemic as students face issues with understanding important concept of electrical engineering. Now, we want to assure you all that maximum syllabus of irrespective whichever state you belong would be covered and the students are at maximum benefit. Now, the subject is circuit and network and the chapter which is taught is network theorem. As this is an introduction lecture, the topic is basics of circuit and network. So let's begin. Now, in the wireless era, we need to rely on wire as they carry power for various electrical complex. Just look around you, you will find an insight of this subject. Now, let me show the introduction to the topics which would be covered during this entire subject. So the first topic which we will be taking is fundamentals of CN. Later we will be moving to various concepts as you see. Now the important thing which you see in the content is the last two things, that is extensive numerical practice and approach for competitive exams. So we do know that students are only taught of the college syllabus, but we will go a step further and introduce you with various numerical practice and that you are also prepared for the competitive exams of the content which you study here. So let's begin. So the first thing which a student would raise question is why to study this subject. Now if you see around you, you will find that there are so many electrical equipments which run on wire as I stated earlier. For example, you might be watching this video on a laptop, on a mobile or even on a TV. And there are many other gadgets which are systematically designed by electrical engineers. Now they are done so to improve the quality of life we live. So to study circuit and network, we should know the analyzing thing. Okay. So a circuit and network is a subject is it is a branch actually which is described as the phenomena that deals with mathematical models. Okay. So all these elements which you see around, they are mathematically modeled and brought on paper. So physical circuit is an interconnection of different apparatus, but to draw it on a paper, we symbolize them. So circuit and network is nothing but a subject where one studies various concepts to understand and analyze the behavior of various components which are part of the circuit. Next question should be why to analyze it. So analysis is an important part. Whenever we study a certain topic, we should always try to analyze as it is a engineering subject. Circuit and network, whenever there is a question, it would be either in what or why form. So when we say why to analyze, it can be said that circuit can be linear or non-linear. It depends on the behavior of output components. It can be active or passive, which depends on the type of source connected, or it can be even open circuited or short circuited sometimes. So we don't know actually the condition of the circuit. So we hence need to analyze it. Sometimes even the effect of time domain or frequency domain concept arise. So it also depends on the conditions which a user puts. And sometimes maybe it is just to find an unknown parameter. So the list here shown may be the possible thing a user might be looking for. So hence we need to analyze the circuit whenever we study this subject. Over here you can see a figure which consists of three main components, that is a source, a load and circuit elements. Always remember that circuit elements are neither always connected in series nor they are connected always in parallel. They can be in any fashion. Only thing you should know is that they become an important part of this circuit. Now, if you vary source, there would be some effect on the load. If the load is varied, there would be effect on the circuit elements and the source too. So all the elements which are present inside this circuit can be said as they all are relying on each other. Any change in any of the element will affect the other element. So we can say that a circuit is dependent on the type of source which it is connected, which may be either AC or DC source, and they can be further categorized, which we will be studying. It can be dependent on the behavior of element. So if it is a resistive circuit, whether it is an inductive circuit, whether it is a capacitive circuit, or maybe it is a non-linear element like diode, semiconductor elements. And sometimes it is also dependent on the type of load which it is connected. So characteristics of load also determine how the circuit would behave. So these are the things which one should analyze whenever he or she studies circuit and network. So there are some important terms involved whenever you study. First is network theory. So this is actually a concept which is brought to understand that this subject involves various parameters which could be solved either by simplifying a circuit, or you can say that you can modify a circuit. It is just to make a circuit look simple so that he or she can identify the element which he wants to find the unknown values. And sometimes the main intention would be the same as to solve the circuit problems. So network theory can be said as a proven concept that helps us to analyze circuit and determine various parameters by simplifying a circuit. Next is electrical network. So what is electrical network? So electrical network can be said as it consists of various elements which are connected. Okay, and all the elements which are connected forms a closed path. So it is an interconnection of elements or devices. Next is an electric circuit. So electric circuit can be said as it is a real representation of electrical system. Okay, so you can say that it is a mathematical model. Now, why it is mathematical model? Because we write certain equations which are involved, which show the relation between each and every element present in the circuit. So it can be said as a mathematical model of real physical electrical system. Or it can also be defined as a network providing one or more closed path. So you can say that an electric network which has one or more closed path can be said as electrical circuit. Okay, so one should remember that every circuit is a network, but not all the network are circuit. As we see that network with one or more closed path can be said as a circuit, but the same thing cannot be said as a network. Next is AC and DC network. So as we see that electrical circuits are mainly categorized into two parts, that is AC and DC. Both have different effects on the circuit. So we know since 12th we have studied, or even in diploma we have studied that AC and DC network have different significance, as AC is dependent on three main quantities which we will be observing, and DC is dependent on few less quantities as compared to AC. So what are these? So we analyze time domain and frequency domain effect. So whenever an AC network is involved, we can say that it is sine omega t, where we can analyze time domain effect and frequency domain effect on the system. Sine wave can be represented in a circular fashion when it completes a 2 pi. So over here you can see green color circle which represented by a red dot which completes one complete whole circle in 2 pi radians. Let us also bring a sine wave. Now this sine wave is a replica of the circle with a function of sine omega t. So over here you can see that the time when this red circle begins from 0, it is the same time at which this second figure will start from the 0. So let us start the circle from the same point. So over here you can see both the circles complete at the same time and they cross pi by 2, pi, 3 pi by 2 and 2 pi at the same instant. So you can say that a sine wave can be represented in the form of circle as it completes its magnitude and its 4 quadrants in the same interval. So over here you can see a black dot at the center of the circle. This center of the circle dot represents the magnitude of the sine wave that is changing at every instant. So you can observe that with the change in magnitude of sine wave, so you can see here that black dot represents the continuous change in magnitude of a sine wave. So whenever this sine wave is increasing function in 0 to pi, this black dot would be going upwards to pi by 2, and from pi to 2 pi you can say that the black dot should be going downwards as it represents negative magnitude. Here you can observe that black dot crosses red dot exactly at pi by 2 and at 3 pi by 2, which represents that it is the maximum value at pi by 2 and it has the negative maximum value at 3 pi by 2 and it is 0 at 0 and pi degrees. Next, we will see that the first effect is the phase angle change. So if you shift this sine wave with some angle, so over here you can see this is a sine wave which is exactly in line with the above figure. If we shift this sine wave with some angle, so over here you can see there is some angle at which this below sine wave is shifted with the above reference figure. So now if you see the crossing time, they would be different. So let's start and see. So you can see the above figure completes its reference time before the below figure finishes it. So you can see that there is a phase angle effect in the second figure. Next effect in AC network would be the frequency. So frequency can be said as number of cycles the waveform repeats itself within a given time. Okay, so over here you can see if 2 pi is the time period, over here you can say that in the below last figure you can see that sine wave is repeating twice the original function. So you can say that frequency of the sine wave is doubled. So over here also if we start, then what should occur? So you can see that time taken for the above figure to reach 2 pi is the same time taken for that below figure. It crosses the 2 times the sine wave. Now after that there is a third parameter which is magnitude. So let us double the magnitude. So the sine wave should be looking like this. And now if you try to start it from the origin, you will be seeing that it is the time taken by the same sine wave. It would be double the magnitude of the origin. Next is the component participating in the network. So in an AC network, inductor and capacitor have two different effects, or you can say that these two effects cancel out each other, and resistive effect is negligible as compared to the other two, because resistor behaves same as it is in AC network as to that of DC network. Next is DC network. In DC network, we mostly analyze the effect of magnitude or amplitude. So we analyze the time domain effect of DC network as there is no frequency domain effect. As frequency is zero when we see a DC network, so we only analyze the magnitude and the components that are participating in the network. Now there are some basic definitions which we will be seeing from the same figure which we started with. So here there is a load, a source and a circuit element. Considering the following system, here loads demand always energy to do some useful work. So you can see this red blinking load demands some energy to do some useful work. So who will provide the energy? So it is the source who will provide the energy. Now source always delivers the required energy so that there is a continuity of work. Now you might be wondering what is load and what is source. Load is nothing but you can consider a ceiling fan, that is also a load, which is trying to give you air or wind through mechanical force. So that energy required is electrical form is converted to mechanical form. So to do so, it requires some energy which is given from the source that may be coming from the distribution company. So here load demands energy to do some useful work which is provided by the source, which delivers that same required energy so that there is continuity of work. Continuity of work is an important aspect in electrical network as load working should be continuous as and when required by the customer. So the source has to facilitate the amount of energy required at every instant to the load. Next is the circuit element that can be an important part of load or it can be sometimes connected separately. Now, all matters are made up of some fundamental building blocks which are called as atoms. So these green dots represent an atoms which consists of three most important particles, that is proton, electron and neutron, where proton is positively charged, electron is negatively charged and neutron is neutral. And Charles Coulomb calculated that force between two charge exists, and that is an electron has a charge which gains some drift, and as a result electrons move from one place to another, that is from negative to positive, and that electron has a charge which is of 1.6 into 10 raised to minus 19 coulomb, and this charge is the electrical property of an atomic particle which a matter consists. So these electrons gain drift and as a result they try to move from source to load and back to source. But the phenomenon of transferring charge from one point in a circuit to another point is described by the term current. So these blue dots represent current. Now the actual direction of current is always opposite to the flow of electrons. So you can say that as soon as electrons start to flow from source to load and back to source, current will start to flow from source to load. So over here you can see that blue dot will now move from source to load. So you can say that current is nothing but the time rate of net motion of electric charge across a cross section of conducting material, or it is sometimes said as the time rate of flow of electrons. Now you should know that as it is a time rate, I is equals to dq by dt. One must remember that random motion of free electrons in a metal does not constitute a current unless there is net motion of charge with time. As there is motion of current, that is current is moving from source to load, as it is load is demanding some energy, there is a voltage, that is potential difference. So the work done to transfer this unit charge from one point to other is called as voltage. So energy required to move a unit charge from reference point to another point can be said as voltage. As a result of current and voltage, power is either delivered or absorbed. So whenever a source delivers a power, we say that it is the current which is moving from higher potential to lower potential. So if you are asked to judge whether a source is delivering power or whether it is absorbing power, you should always see the direction of current. So if the current is coming outwards from the source or an element which is shown to you, suppose it is a battery, then if the from the terminals of battery, if the current is coming out, you can say that power is delivered. If the current is coming inwards, you can say that power is absorbed. So you can say that from the definition, power is the time rate of absorbing or delivering energy. Next is the circuit elements. So one should know the history of the circuit elements as they were derived or invented experimentally. So German physicist George Simon Ohm found experimentally that there is a relationship between current in a substance and a potential drop, and this came to be known as Ohm's law, and after his name a unit was named as ohm, and that is nothing but resistance. So this resistance is the property of an element to oppose the flow of electron. So as a result, resistance unit was named after him, ohms, and the famous formula of Ohm's law, that is V is equals to IR. Now after resistance, then the next element is inductance. So in 1820, Oersted made an important discovery demonstrating that force between two charged substances depend on time rate of flow of charge. So Oersted invented that there is a time rate of flow of charge indicating the effect of magnetism. So there was an element that showed the magnetism property. Similar thing was observed by Faraday, who also experimented with two conducting circuits in a spatial proximity, showing the effect of changing magnetic field produced by one circuit, induced voltage in other circuit. And finally, the work done by Joseph Henry gave the credit to the inductor, and the unit of inductance was named after him, that is Henry, and the symbol is H. So inductance can be defined as the property of an element that doesn't allow abrupt change in current, which means that if there is a change in source, there is no sudden change in current. There will be certain time taken by which is taken by the inductor to change it the current value from one value to other. So after inductance came the another element, that is capacitance. So there is also a history behind the invention of capacitance. So the first effect of capacitance was observed by Ewald George. Now sometimes he told that there are charges present between two spatial separated substances. In 1745 he found this effect, who is a German physicist, and in 1776 Alessandro Volta came with relation of proportionality between V and Q, that is voltage and charge, which is known as the law of capacitance and is called as condenser. So at this time the name of capacitance was known as condenser. It was later in 1830 when Michael Faraday and his experiments of specific inductive capacity coined the term capacitance, and the unit was named after him as Farad. Now, capacitance is nothing but the property of an element that doesn't allow abrupt change in voltage. So as capacitor has plates, so it stores charge in between those two plates, and these two plates are of metals, and in between them there is a dielectric material. And this dependence of capacitance parameters was found by Michael Faraday. He found the effect of change in area, the thickness of plates, and the dielectric material. So hence the name of unit was named after Michael Faraday, that is Farad, and it is named as capital F. Then there are some further basic definitions which you should know. It is a branch. It represents number of elements present in the network. So over here you can see a figure where A, B, C, D, E, F, there are some points which are located in the circuit, and there is capital V which is a voltage source. Just now it is not defined whether it is a AC or DC, but there is a source connected to a resistive network. Why a resistive network? Because all the elements are resistive in nature, that is connected to the source. Now what is a branch? So as it is written, it represents number of elements present in the network. So suppose you can observe that there are so many elements present between 2 points. Suppose there is, you can name an element 2 ohm of resistance between A and C. So first branch would be AC. Similarly, you can observe other branch that is CE, and you can find other branch that is EF, CD and AB. One should note that any element present between 2 points can be said as a branch. Next, one should know the other definition, that is node. So node is the point of connection between two or more branches. So as you can observe, between two branches there is a node. So in between AC and CE there is a node present, that is point C, and similarly point D also is a node. Next is a loop. So a loop is a closed path in any given circuit. So loop is always starting from one point and ends at the same point. So first loop is, suppose it is starting from A, then it will move to C, then to D, then to B, and finally A. So it should start with A and end at A. Similarly, there is second loop which is C, E, F, D, C. And finally, there is a bigger loop which if you observe, it would be A, C, E, F, D, B, A. Okay, so it is starting from the voltage source, it is moving forward to the branch AC, then it is moving further to the branch CE, then to the branch EF, then finally from F to D to B, and finally to A. So this is the third loop. So this circuit consists of 5 branches, 2 nodes and 3 loops. So any circuit, there would be a branch, either node or a loop. So any of them you should be able to observe. Let us classify the elements. So elements can be classified based on the variety of things which you observe according to their behavior. So the first thing is based on the physical dimension. So based on physical dimension, elements can be classified into two main categories, that is lumped and distributed. Next, it is categorized based on linearity property. It is either linear or non-linear. Elements can also be categorized based on the relation they gain between V and I, or for even the reverse polarities of the source. So based on this polarity of reversal, there is two things which elements depend, that is unilateral and bilateral. Next is based on the source connected. So based on the source connected, a circuit can be either active or passive. And finally, it is based on the delayed time response. So based on the delayed time response, an element is categorized into two things. First is time variant and second is time invariant. We would be observing about the classification of elements into depth in the next video, that is the classification of elements. I hope that you all like this video and that you come up with your interesting ideas and reviews on the video posted. Please like, share and subscribe the channel and the content if you like.